Hi everyone, so welcome to the part 3 video of acid, bases and salt. I would again request you to watch part 1 and part 2 video before coming to part 3 so that you have a more clear understanding, and I will link the part 1 and part 2 video of acid, bases and salt in the description box. So as of last in the part 2 video we had discussed about the different types of indicators. Uh, One last type of indicator which is there called the universal indicator. Now what is a universal indicator? The universal indicator is made by mixing of all the different types of indicators. When we test through universal indicator, you will find that in your lab uh, of your in your chemistry lab, and you will see in the bottle also of the universal indicator there is a color code which is given, right? So if it is a neutral, means if the solution is neither acidic nor it is basic, then it will give you a greenish yellow color. And accordingly, if it is acidic and more acidic, the stronger, if it is a very strong acid, it will give red color. If it is a weak acid, then it will give a different color towards a orange color. Similarly, we can also test the strength of the base. If it is a strong base, it will give a darker shade. If it is a weak base, it will give a lighter shade, the bluish shade. So you test the solution with the universal indicator, and then whatever color you are getting for the solution, you match it with the index, that color index in the bottle, and accordingly you can find out whether it is a strong acid, weak acid, whether it is neutral, or whether it is a strong base and weak base. Now a very common question which is asked, I have seen this question many times in the question paper, that what is the difference between a normal indicator which we are using for testing any acid base. For example, litmus. If I give you a litmus and if I give you a universal indicator, what is the difference between both of them, right? So the answer will be, with the help of litmus I can only identify whether it is an acid or whether it is a base. You know that in acid the litmus will change to red color, and if it is a base the litmus will change to blue color. Same goes for methyl orange or phenolphthalein. But if I use a universal indicator, then I can not only find out whether it is an acid or a base, but I can also find out whether it is a strong acid, a weak acid, a strong base or a weak base. So this is the difference between the common indicator which we are using for testing acid base and a universal indicator. In case of universal indicator, I can find out the strength of the acid or the base, and even if it is neutral, that also we can find out, right, with the help of a universal indicator. That is not possible with the help of litmus. I cannot find out whether it is a neutral solution or whether it is a strong acid or weak acid or strong base or weak base. I cannot do that with the help of a litmus. So here comes the use of the universal indicator. There is one more paper which you will find in your chemistry lab, which is called the pH paper. We will talk about pH, but that will come in the upcoming video, not today. Right, now we will come to the chemical properties of acids and bases. There is one picture in your textbook which I am linking over here, and you have seen this picture in the lesson acid, bases and salt. Now what is happening in this picture? First we take dilute sulfuric acid. Now what is the formula of dilute sulfuric acid? The formula for dilute sulfuric acid is H2SO4, right? Into the dilute sulfuric acid, now we are adding a metal. Okay, here we are using zinc granules. So we have taken a dilute acid, the sulfuric acid is dilute. I have taken a dilute acid, and to this I am adding a metal which is a zinc granule. What is the formula for zinc? It is Zn. Now what will happen? You notice in the diagram that you can see there are bubbles which are coming out in the test tube. What does this emission of bubble indicate? This bubble indicate that there is some gas which is being formed. So when an acid reacts with a metal, a gas is being liberated, and along with the gas a salt is forming. Now what will happen in this case? Which salt will form in this case? Let's have a look. So I am having sulfuric acid, H2SO4. Into that I am adding a metal which is a zinc. I will get ZnSO4 salt, and I will get a gas which is hydrogen. Now because it is a gas, I will give an upward arrow. Okay, that's what you see in the picture. There are bubbles which are coming out, which is a gas which we call as hydrogen. Now I am telling you hydrogen, but how will you know that whether it is hydrogen only, it is not oxygen, or it is not carbon dioxide? How come I test this gas hydrogen? How will I identify that this is hydrogen only? Now to test hydrogen gas, if we bring a burning splinter or a burning candle near the hydrogen gas, it will burn with a pop sound. You will clearly be able to hear a pop sound. So from the test tube, when this gas is coming out, when I collect this gas, or if I bring a burning matchstick, a burning candle near the mouth of the test tube, I will be able to hear the pop sound. Okay, so you will be doing this experiment in the lab, and you can very clearly hear the sound, the pop sound of hydrogen gas, and through that pop sound we can conclude that the gas which is being emitted in this reaction is hydrogen gas. So what happens when an acid reacts with a metal? If I take an acid and if I react it with a metal, I will get salt plus hydrogen gas. Okay, in place of H2SO4 I can also use dilute hydrochloric acid. If I use dilute hydrochloric acid, then instead of getting ZnSO4 zinc sulfate, I will get zinc chloride. So always remember, whenever a metal is reacting with an acid, I get a salt and plus I get hydrogen gas. Now a common example of this in your daily life. Have you ever eaten curd in a copper, in a container, in a bowl or in a plate made up of copper? Or have you ever drank anything sour in a copper glass? If you will notice that after some time, if I keep the curd in a curd rice, if I keep it in a copper container for some time, when you taste it, you will see that the typical taste of curd has changed. What is the reason for it? Being a chemistry student, you will be able to identify it now. Curd has an acid, it has lactic acid. Lactic acid will react with the metal and it will change to a salt. Hence, the acid is getting broken down. The lactic acid is changing in its composition, and that is the reason why we are getting a change in the taste. Okay. Now this is about acid. What happens if instead of an acid I use a alkali? Instead of an acid I use a base. Then what color change will I get? Let's have a look. Instead of an acid, if I take an alkali or if I take a base, and along with the base I react with a metal, I will get the same product. I will get a salt and I will get hydrogen gas. Let's see an example. If I take a base NaOH, which is sodium hydroxide, caustic soda, along with it let's take the same metal, zinc. Okay, and what will be my product? It will be Na2 ZnO2, sodium zincate. The name of this compound is sodium zincate, and along with it I will get hydrogen gas. Again, I can identify the hydrogen gas by following the same test, which is bringing a burning candle or bringing a burning splinter, and I will hear that characteristic pop sound. So both acid as well as alkali, okay, both acid as well as an alkali. If I take an acid or Or if I take an alkali and I react it with a metal, I will get the same product, which will be salt plus the hydrogen gas. Okay, so acid and alkali reacts with a metal to give salt and hydrogen gas, right? So this is the first chemical property of acid and bases. Okay, now if I take a carbonate salt, right, now so long I took a metal and I reacted with an acid. Instead of this metal, in the second property, if I take a carbonate salt, for example, if I take sodium carbonate, what is the formula for sodium carbonate? Na2CO3. Instead of a sodium carbonate, if I take a sodium bicarbonate, the formula for sodium bicarbonate is NaHCO3. Right? In both the cases, both in case of the carbonate and in case of the bicarbonate, if I react it with an acid, for example, let's take hydrochloric acid, HCl. Let's see what will I get. Now notice over here, it is a carbonate or it is a bicarbonate, bicarbonate or hydrogen carbonate. Being a carbonate salt, can you guess what gas it will release? You are right, it will release carbon dioxide. Okay, so what will be my product? Again, I will get a salt. I will also get water and CO2. Same thing for the bicarbonate as well. Both the carbonate as well as the bicarbonate, the hydrogen carbonate, when it reacts with an acid, will give the same product, which is salt plus water plus carbon dioxide. Once again, if I take a carbonate salt and if I take a bicarbonate or a hydrogen carbonate and if I react it with an acid, then what will I observe? I will observe that carbon dioxide gas is being released. Along with it, I will get salt and water. So sodium carbonate or sodium bicarbonate plus HCl plus hydrochloric acid gives salt plus water plus carbon dioxide. What is this salt? It is the common salt NaCl. Because I have taken sodium carbonate, I am getting NaCl. Now again, I am telling you carbon dioxide gas is being released, but it is a colorless, odorless gas. How will you identify that this gas is carbon dioxide? Okay, now carbon dioxide has many tests, but one of the most confirmatory test is when I pass carbon dioxide through lime water. When I pass carbon dioxide through lime water, the lime water turns milky. Now why does the lime water turn milky? The lime water turns milky because it forms a white precipitate. What is the formula for lime water? Lime water or slaked lime. Now what is the formula for slaked lime? Slaked lime is CaOH whole twice. Okay, this is the formula for lime water. Lime water is not lemon and water. Please make it very sure. There are many children, many students who think that lime water means lemon water. No, lime water is not lemon water. Lime water is calcium hydroxide, CaOH whole twice. It is also known as slaked lime. Now do you know what is the formula for quicklime? Quicklime is CaO. Okay, quicklime is CaO. This is the formula for quicklime. And CaOH whole twice is also known as slaked lime. Now when I pass carbon dioxide gas through slaked lime it will turn milky. It turns milky because of the formation of the white precipitate called CaCO3 plus H2O. Okay, this CaCO3 calcium carbonate forms the white precipitate, and that is the reason why the clear solution of lime water turns milky when I pass carbon dioxide through it. So when this gas is released, when I take carbonate or a hydrogen carbonate salt, a bicarbonate salt, and I pass acid through it, okay, and I add acid through it, I get one gas. A colorless, odorless gas is coming out. This gas is carbon dioxide. How do I test whether it is carbon dioxide? When I pass carbon dioxide through lime water, which is calcium hydroxide, the lime water turns milky because of the formation of CaCO3, which is calcium carbonate. Now, here I am passing only little bit of carbon dioxide. If there is any student who becomes over ambitious and goes on passing lots of carbon dioxide through the slaked lime, then what will happen? Understand this very carefully. When I pass carbon dioxide through a clear solution of slaked lime, first the slaked lime will turn milky because of the formation of calcium carbonate. But if I pass carbon dioxide after it turned milky, I go on passing carbon dioxide. So if I pass excess of carbon dioxide through slaked lime, this milkiness will disappear. Why this milkiness is disappear? Now let's see. First, I had a clear solution of slaked lime. I passed carbon dioxide through it. It turned milky because of the formation of calcium carbonate. So I have this milky solution of calcium carbonate, CaCO3 plus H2O. Okay, I have this milky solution of calcium carbonate. Into this milky solution, I pass excess of carbon dioxide. I keep on passing more carbon dioxide. I pass excess of carbon dioxide, and this milkiness disappears because when I pass excess of carbon dioxide, I get CaHCO3. CaHCO3 calcium bicarbonate is soluble in water. Because of the formation of calcium bicarbonate, on passing excess of carbon dioxide, the milkiness disappears, right? So today we learned two chemical properties of acids and bases. In the first property, we saw that acid reacts with a metal to give salt and water, or alkali reacts with a metal to give salt and water. And in the second reaction, we saw that carbonate or a bicarbonate salt on reacting with an acid gives a salt, water and carbon dioxide. Whenever there is a carbonate salt or a bicarbonate and I pass acid through it, I get carbon dioxide along with salt and water. Now how will I test whether it is a carbon dioxide? I pass the carbon dioxide through slaked lime, okay, through lime water. I pass it through lime water, and that lime water turns milky because of the formation of calcium carbonate. If I go on passing carbon dioxide through this milky lime water, when I pass excess of carbon dioxide, that milkiness disappears. That milkiness disappears because of the formation of calcium bicarbonate. Now these reactions, whatever we discussed today in this part, are very important. All of them are there in your NCERT textbook. I would now request you to kindly go through your textbook. I will also do one more video where we will discuss the NCERT text in detail. So hopefully you have understood whatever we discussed till now. If you have understood, please give me a thumbs up. See you soon in the part 4 of acid, bases and salts. Thank you.